So last class we solved problems in Z transform. Some more problems are there, we'll solve. So purely left side signal or a right side signal, that those problems already done. If it is left and right, how we can do it. So another example, x of n equal to the power of n u of n plus 2 power n u of minus n minus 1. So this is a right side sequence, whereas this one is left sided sequence. Previous two models, both right, both left done. Right and left. So how to solve? X of z is, it is a right side na, 1 by 1 minus 1 by 2 z inverse. And here it is, remember this, minus a power n u of minus n minus 1 z transform is 1 by 1 minus a inverse z. But here plus is there, so it is minus of minus. So here minus 1 by 1 minus 2 z inverse. But because it is right side, mod z greater than a is 1 by 2. Whereas here left side, mod z less than 2. Less than 2. So greater than of less than 2. So what is the final x of z is? Take LCM and simplify. You get minus 3 by 2 z inverse 1 minus 5 by 2 z inverse. So ROC mod z less than 2 greater than 1 by 2. So this is the answer. Z transform, always we have to mention ROC. Always we have to mention ROC. So this is the problem with the numericals. X of n is delta of n. So what is x of z? Sigma n equal to minus infinite to infinite delta of n z power minus n. What is this delta of n? Is a unit sample. Unit sample. Delta of t is a impulse. Delta of n is a unit sample. So how it is defined? Delta of n equal to 1, n equal to 0, equal to 0, n not equal to 0. So its value is 1 only at n equal to 0. So therefore at n equal to 0 in the expansion you get 1 into z power 0, 1. So what is the answer? 1. So therefore z transform of delta of n is 1. ROC is entire z plane. ROC is entire z plane. Next is z transform of u of n. U of n. U of n is unit step. Unit step. So this is equal to 1, n greater than or equal to 0, equal to 0, n less than 0. This is u of n. So to find z transform, x of z equal to minus infinite to plus infinite u of n z power minus n. But u of n is 1 from n greater than or equal to 0. So n equal to 0 to infinite, this value is 1, z power minus n. So what is this summation is? 1 by 1 minus z inverse. Here this value is 1. So 1 minus 1 z inverse. And ROC mod z greater than 1. ROC mod z greater than 1. This is nothing but z by z minus 1. Any one of the format you can show it. Next, x of n is minus u of minus n minus 1. So this is again x of z sigma n equal to minus 1 to infinite. Minus 1 to minus infinite, or minus infinite to minus 1. Minus infinite to minus 1, only this value is 1 into z power minus n. So this you simplify. What is the easy way of doing? Minus a power n u of minus n minus 1 z transform is what? 1 by 1 minus a z inverse mod z less than a. The same formula, a equal to 1. So you get 1 by 1 minus z inverse mod z less than 1. So answer same, only thing is here less than 1, previously greater than 1. Next, x of n is u of minus n. U of minus n. So x of z equal to sigma. Here u of minus n. U of minus n. U of minus n is like this. Zero, minus 1, minus 2, minus 3. This is 1. This is what u of minus n. Un folded u of minus n. So its value is 1 from 0 to minus infinite. So n equal to minus infinite to 0. Its value is 1. Then z power minus n. So this is nothing but sigma n equal to 0 to infinite 1 z power n. 1 into z power n. So answer is 1 by 1 minus z. Okay. 1 by 1 minus z. Mod z less than 1. Mod z less than 1. Next problem, x of n equal to a power mod n. A power mod n. And there are two cases. Case 1, a is between 0 and 1. Case 2, a less than infinite to greater than 1. So for both the cases we have to do it. So this is a power n u of n for n greater than or equal to 0, equal to a power minus n u of minus n minus 1 for n less than 0. So this is left side a power minus n, right side a power n. That means I can write x of n as a power n u of n plus a power minus n u of minus n minus 1. So what is x of z? Right side 1 by 1 minus a z inverse minus of, this is minus of minus. So we can write 1 by 1 minus, here a inverse z inverse. Whereas in this case right side na mod z greater than a, here left side mod z less than a. So final answer is here less than 1 by a. Less than a inverse means 1 by a. So simplify this answer is a square minus 1 by a z by z minus a z minus 1 by a. And what is ROC? Mod z greater than a less than 1 by a. So this is the answer. This detailed simplification steps I am not doing, but simplify you get this answer. ROC is important. So this is the specialty of problem. A mod n. For positive value a power n, negative value a power minus n. This is in case 1. If it is in case 2, so why this problem is important? A between 0 and 1. Let us take a equal to 0.5. If a equal to 0.5, what is the ROC? This is unit circle. This is a 0.5 circle. 0.5. So mod z greater than 0.5, less than 1 by 0.5. Less than 1 by 0.5 is 2. So draw another circle at 2. So less than 2, greater than. So this is the ROC. This is the ROC. Okay. Greater than 0.5, less than 2. So this ring, this is the ROC. Whereas second case, a between 1 and infinite. If I take a equal to 2, mod z greater than 2, less than 0.5. Greater than 2, less than 0.5. How to show that? This is unit circle. This is 0.5. This is 2. 2, 1, 0.5. Less than 0.5 is this. Greater than 2 is this. So there is no overlapping. Less than 0.5 is this. Greater than 2 is this. So there is no common overlapping portion. Therefore, Z transform not possible. ROC is unable to define. Greater than 2, less than 0.5, it is ambiguity. So you can't choose by satisfying both the conditions. Therefore, ROC inconsistent, ROC unable to define because there is no overlapping. Hence, Z transform not possible. So Z transform not possible here. Not possible. First case possible, second case not possible. Another problem, x of n is a power n equal to 0 elsewhere. So this sequence is present from 0 to n minus 1. a finite duration sequence. Now x of z is 0 to n minus 1, n equal to 0 to n minus 1, a power n, z power minus n. This is nothing but n equal to 0 to n minus 1, a z inverse to the power of n. Here if it is 0 to infinite we have an answer, but 0 to n minus 1, as per mathematics you are aware of it, you get 1 minus a z inverse to the power of n by 1 minus a z inverse. So this is the answer. This ready-made answer, you remember that. There is a formula for that, you accordingly you write. So when we simplify this further, 1 by z to the power of n minus 1 so we have a pole at z equal to a, we have a pole at z equal to 0, we have n number of zeros, so z power n minus a power n equal to 0, we have n number of zeros, so that is decided by a e power j 2 pi k by n. So n is this, change different values of k, accordingly you get all possible n number of zeros. So what is z0 is a, because k equal to 0, so there is a 0 at a for k equal to 0. There is a 0 at a for k equal to 0, and there is already pole at z equal to a, that 0, this pole will cancel, n minus 1 zeros are there and n minus 1 poles at 0 are there. So that is generalized expansion. Generalized expansion is this. So we can write x of z as z minus z1, z minus z2, so on, z minus z n minus 1. So n minus 1 zeros, z to the power of n minus 1. So we have a n minus 1 poles at z equal to 0. These are the zeros, n minus 1 number of zeros. This is x of z answer. Another problem, x of n equal to sin omega naught n u of sin omega naught n u of n. So this we can write it as 1 by 2j e power j omega naught n minus e power minus j omega naught n. So what is x of z? 1 by 2j is common. So indirectly z transform of this. So this is like a. So a power n. If it is a power n, how you write? 1 by 1 minus a. A is e power j omega naught z inverse minus 1 by 1 minus e power minus j omega naught z inverse. So this you have to simplify. And mod z, it is because of un. Un means right side. Right side means mod z greater than mod e power j omega. So it is greater than 1. Magnitude of e power j omega naught is 1. So mod z greater than 1. So simplify carefully. You get to z inverse sin omega naught by 1 minus 2 z inverse cos omega naught plus minus is the answer. Similarly, cos omega naught. So this you try homework. You get 1 minus z inverse cos omega naught by and mod z greater than 1. So answer I am giving. Sine converted to exponential, cos also convert to exponential. Simplify, you get this answer. So sequence can be x of n 1, 2, 6, minus 2, 0, 3. Arrow is here. Arrow indicates n equal to 0. Minus 1, minus 2, plus 1, plus 2, plus 3. So here sequence is given, not the signal. So to find the z transform. So x of z will be 0, minus 1, minus 2. So sigma n equal to minus 2, 1, 2, 3. So n equal to 3. Then sequence x of n, z power minus n. So you will get z square 2z plus 6 minus 2 z inverse 3z power minus 3. So if you substitute x of minus 2, you will get 1. Z power minus of minus. So z square. Like that, substitute and expand, you get this. What is ROC? Except r equal to 0 and r equal to infinite. If r is 0, if it is 0, this become infinite. If it is infinite, this become infinite. So x of z should not be infinite. It is not infinite for any value of ROC except 0 and infinite. So that is the meaning of this. So next class we will study properties of Z transform. So till now we have seen how to find the Z transform of different sequences, how to find ROC, etc. Next class properties. After properties, inverse Z transform, like that it will go.